Okay. Let's begin with making a test code, I guess. So I'm gonna have a class foo, which has a public enum do enum types. Let's say it is a private variable int x. So just put it to initialize that to 42. Let's begin. Well, let's put it in the namespace as well, of course. Channel and stuff. So I'm gonna create a foo here. Now what already works is I can write stuff to an O stream. Yeah, this is a macro that just writes to an O stream, just like standard cout and then less than foo. And that already works with utils, has print on. I'm gonna steal from that like crazy, so let's make that work. Yeah, that is this header. And here's example code. It says that we have to add this at the top of the namespace where we have a class that has a print on like that. So in this case, that one, and then let's say I'm adding my print on here. So this just prints the value of the foo, which is always 42. So I'm just gonna print x. So this should already work. I'll just create a foo here now with an internal representation of 42. And if I try to print it to an O stream, that is just writing foo to an O stream. Maybe I don't know. It's like a standard cout less than foo, like I said. It's going to use an operator less than that exists or can be used because this exists, and therefore it's just going to write x, which is 42, so it should be writing 42. To add this thing to its own test. Add executable. Yeah, then I'm just gonna call it toString expose. Crazy. What the F is it doing? It should not be possible that it takes so long. Is that a matter of DNS being this slow? Because it's basically the last thing I changed. That wouldn't be very good. Took like 5 seconds. Oh yeah, never mind. Now it works. I'll have to make an alias for that first. It should already exist. Oh no, I have to resource it maybe. To string. Yeah, that prints nothing. Okay, that's not using debug. It's strange. It totally should be using debug. No. Suppose now it is. Yep. I defined this. Or now we should definitely have output. Yep. 42. Okay, so you can write to an O string because foo has a print on. And how does that work? Well, I already had that. That works because I'm including has print on. And then we do this. Using this operator inside this namespace. Which means that if you call this function, now maybe foo is defined inside namespace test. No, I'm not so sure actually. Let me just look at the definition here. Okay, I was confused. I thought it was the operator already. Has print on is a namespace. So rather, well, no, never mind. It's not true. I'm using this operator defined in the namespace has print on. And we're putting it in test. So now inside namespace test, we have the same operator less than defined. So this one. It's now defined inside namespace test. But then why would we use it, right? I mean, is that ADL? I mean, our T that we try to print is in namespace test. Is it then going to look in namespace test? Yeah, of course it is. Yeah, So ADL stands for argument dependent lookup. So it's going to search in the namespace of the namespaces even of all the arguments, the namespaces of all the arguments that you pass. So in this case, we are trying to print foo defined in namespace test. Therefore, it's going to search in namespace test for this operator. Yep. So here we're trying to call operator less than with this argument something in namespace test. Therefore, it's going to look for operator less than in namespace test. So that's called ADL. And it finds that one because namespace test is including the operator less than that it was defined in utils has print on. Whereas print on is a namespace, but okay. So it's going to consider this one because of ADL and that using. And then, well, it's only going to consider it if this thing has a return value that makes sense, which means that the enable if type must actually, I would say, resolve or something to the standard OStream reference, which is it only going to do if this expression is true. So if t, which is my test foo, if that has a print on, and it does, then this will be true because of how we defined that. I mean, it's like equals true. And this is an I'm thinking of the word. Is there overload here? So normally, by default, it's false. And no, this is specialization rather. So we make it. It's a template, and then if t is just t, and then this the template has two arguments. The second argument is by default void here, but in the special case that it is the type returned by this standard void type, which is going to be a type that only exists if for this t, the declaration value of t, we make a value of that, and then we can call print on that. So it's just a difficult construction here, but since this thing exists, it is a member function of t. This whole type is going to exist, and then it is more specialized than that one, and therefore it will pick this one, which is equal to true. Therefore, for any class that has a print on member function, this operator less than is going to be well enabled to exist. Okay, now we're going to do the exact same thing for toString. There are two possibilities. I just have a const expression standard string toString as a member function, or foo, so that would serializing foo to a string. I could of course use print on, write to an output string stream, but I guess it's slightly slower than calling this function if you have it. So if this exists, then we want to use this. Maybe I should even make implement something that if the print on exists but the toString does not exist, that this toString still works, because then it will fall back to, say, the print on, print it to an output string stream using the print on to get this string. Okay, let's implement this one first. No, let's just return a string here of 42, whatever. I mean, otherwise I literally have to print it to the value is an int. So maybe I should make it a string. That would be less. That it's more obvious than that we would not call it print on. Let's make this a standard string. Let's say if you use print on, I want to let it get something else than when we call toString, because otherwise you can't even test it, which one is being called. So let's say by print on, we print x underscore colon and then the value of x. And in this case, we just print toString is just literally returning x. So one of them has this in front of it and the other one doesn't. So now it exists, it should compile, but still it's not using it or something. It's just using the print on, which is has now an x underscore colon in front of it. Yeah, let's add quotes also. Like quotes here. So this is just print on. And then if you do, if you print, if you call toString on it, I mean, there is a standard toString, right? You know, there's a standard toString exists, but then that can only print the things that the standard toString can print, like int and float and stuff like that. But you should not use the std in front of it, I think, although built-in is then maybe not going to be found. And int is not a class, so it also does not have a namespace, so ADL is not going to work. But if you want to print stuff in general, you just do this, and it's going to use the toString in the namespace of the argument. All right, that's ADL. That's what you want. Argument dependent lookup. So no, nothing in front of it. The whole thing is that we are going to use the toString in the namespace of foo. So we don't know the namespace. It's going to find the correct toString from the correct namespace, depending on the namespace of foo. And yeah, this is in the global namespace. So it's going to look in namespace of foo, which is namespace test. Test itself does not have a global toString. We also include this, but this has nothing to do with anything. It's just operator less than less than. So if we try to compile this, it's not going to compile because it cannot find toString. toString was not declared in this scope. So now we might want to do the same thing as we did here. Include it from another namespace, right? Now, maybe I'm going to be annoyed if I have to do both print on and another namespace. But if I would do that, then it would look like this. On the other hand, why not? Because, yeah, this part is different anyway, so I might as well use a different namespace here. This is not has print on namespace. Well, actually, I'm gonna do has toString, right? Yeah. So for now, I'll just put it here, and then later remove it to a utils header. So I'm going to have in utils has toString namespace. we need this general catch-all toString, just like we had the operator less than there. So it's basically just copying and then changing it from operator less than to toString. It's not that much, it's just this half page here. I'll probably need those headers as well. I'm just gonna copy them, put them here. And then we copy all of this. Oops, Control T. Okay, so we have an has toString, which by default is false. And then we make a specialization. For those types that have the member function toString. toString, and then it's true. Although in this case there is no parameter being passed, it must be empty. It's just no. I mean, print on took an ostream as a parameter, but this thing does not take. This toString does not take a parameter. So if the T has a toString member function that takes no arguments, then this thing is going to exist, which is then true. And then this one is enabled, this one being now also toString. And we don't want the return type to be an ostream reference, we want the return type to be a standard string. And yeah, like I said, oh wait a minute, that's not true of course. This must be, the ostream is gone, but the T must still be there. And then we call toString on the object without an argument, and we can return that. That should return a string. I guess I should test also that this thing has a return type that is convertible to a standard string. That's what we're trying to do. How do you do that? I'm gonna ask it AI because I don't know. I mean, it often gives a wrong answer, but then the compiler will tell me that it is wrong. I currently have this C++20 code. And the letter is a template specialization for types T that have a member function T to string. How do I change this specialization such that it only matches whatever matches if the return type of that member function can be converted to a standard string, question mark. Now it did write its own test suite, so let's just copy the whole thing and see if at the very least it works. Why? As fine? That's like C++ 17. Yeah, so is standard enable if maybe. Yeah, these lines are the only thing that it changed. Standard void type, condition 1, valid expression. So this thing must exist, and then just comma. Oh, it created a... No, it's already have it. Oh yeah, this is just another parameter, I guess. So this thing must exist, and this thing must exist. I'm still not sure why it's not using a concept. This will work, of course, but explicitly said I'm using C++ 20. Yeah, I don't know, maybe. Oh well. Okay, let's see if this makes sense. A comment, standard enable if type. It's going to be, I mean, that this is going to be a type, and then if it is a type, you can use it as a template parameter. Or it is just not going to compile. In which case, the whole template is considered to be non-existent. So if this does not exist, it's going to fall back to this one, which is false. And the type that it uses here is standard string for some reason. Yeah, well, whatever. I think this is the only thing that really matters. That is then the condition. No, wait a minute, that's not true. This whole thing is the condition. So it says if that is convertible to standard string. Okay, so we make again a declaration type of t, then we call toString, and whatever the type of that is well grabbed, as it were. So we pass that to declaration type, then we get the type of what toString returns, and then we say if that type is convertible to a standard string, then this is true, and therefore the enable if type is compilable, I guess. I have the feeling it feels like something is missing here, but okay, well, maybe. Probably I should just look up how it really works, but I'm so lazy. I never actually look at documentation anymore with the AIs around. Ugh, I'm just gonna try this. What the hell? that one belongs to that one, so I wanted that one to line up with this, and then all of this must actually be indented. And this then would be the first condition. It was described as it has to exist or something. It's a valid expression, okay. But it says if the return type of this, that is the call to the member function of data, which is type T, which would be this type, must be convertible to standard string, because you're going to try to convert that to this return type here. Provided that this was true, of course. Now, error, 2 or more data types in declaration of type name. AI slop, or what is it? I just forgot the comma, I think. Template argument 1 is invalid. Namespace SCD does not name a type. It's interesting. That not just must be type traits. No, it just doesn't know what has print on is. Yeah, we were here. I have to still change the rest. Catch all. So now you're going to define the catch all toString for classes with the toString method. Enable in has toString, which was just defined. Oh, I forgot to change this part actually. The rest is already correct. Yes. And it works. Wow. So that was one part. Then the next trick is I want to add an enum here. I already have an enum actually. So you want to do is foo e. Just declare that. Test foo e enum. Now let's give the value 2. And then we want to be able to print that as well. Also using toString, so this is way more demanding. So this is not going to compile because now we have the type E, which isn't even a class, let alone that it has a member function toString. So in this case, foo has a member function toString. Add it here. And therefore, this magic works. It's going to call that member function in the end. But the enum is not a class. It does not have a member function. So it does not have a member function at all. Also not a member function toString. So this is not going to compile. 2 is not declared. So we are mimicking an enum class. Foo has not been declared. Yeah, okay. Test. Foo is in the namespace test. Maybe I should just do using namespace test, but got to work like this as well. Now what? Now exactly what we expected. ToString. No matching function for call ToString. So now I want to add a catch-all ToString that also works if the type is of this form, where foo is a class that defines ToString for that enum. So it definitely must exist first, otherwise we can never call it. So the whole idea is that we want to have an... See, normally you would do enum class E, right? And if you want to have an enum that cannot be converted from or to an integer. But now we want to have... now this is more or less an internal type now. We're not going to use it anymore. So let's fake that. Let's say this is more like the foo E, where we don't want to type foo E, we're just going to type foo. You have foo1 and foo2. So like here, you just have foo2. I'm gonna do the... Let's edit here using namespace test. This is slightly... Oh yeah, okay. Well, even if we want to mimic an enum class, so this should work. But that means that you have to be able to construct the foo also from its own enum. So this is going to add a constructor here for foo that takes E. And then we also must have the enum value itself, of course. So I'll add it here. Oh, it's not added there. Yes, probably should also be constexpr. So now this will compile, and then we want to be able to print the E. And now the type of E is just foo. So now we seem to have a problem, because before it also was type foo. So what this is going to do is, now it's going to say, well, yeah, it's just a foo. Period. I'm afraid this thing is going to use this one. Which, no, I don't want to print the X anymore. I just want the whole thing to act like it is an enum class. So this thing should be printing the value of the enum that it wraps. So now they really do something different. Print on prints x, but if you do your toString, then it just prints the value of the wrapped enum value. So what will happen now, I would say, is it says, okay, E is type foo, and that does have a toString member function, and therefore we use that to get our string. So I think this should compile. Not quite expected. The E does not exist. No matching function, or oh, I don't have a default constructor anymore. Yeah, this is no longer working, is it? We can print foo. Let's say I'm gonna use print on here. That was for the original test, and then let's say we just constructed from an int. I'm going to change x back to an int, I guess. It's no longer a string. And I want to have a constructor that takes an int. This would leave E undefined. That is not a good thing, I suppose. So let's define it to something. Let's say, yeah, well, the default value is 1. So. So this works. Now prints int if you write it to an OStream using print 2. And if you use toString, then it uses the member function toString, which just gives you the value of the wrapped enum. But now there's one more thing then. Because of course since we can type this, the user, it's part of the API of the user, right? I mean, foo2 is a thing, but foo2 does not have the type foo. So if we want to print that directly for some reason, let's say, no, so call this 2. This would work, but if some idiot would be using auto here, then the compiler would have known that we maybe want to convert this always to a foo, and we would have just a type here, the internal type that we never want the user to know about, which is this wrapped enum. So this is foo : foo e. That is the type of e2. And if then you try to use toString on that, then that's not going to compile because that doesn't have a member function. And I want this to see that this horrible type here. I want this to work as well, actually. So now you want to have a catch-all toString that simply works if, 1, this is an enum, the whole type must be an enum, and it must be an enum that is I can't find the word. Oh, yeah, well, defined inside a class. It's probably a better word for it. So this must be a class, and then the class must have a static member function that is able to print this. Or is that nonsense? Because then I have to implement that function twice. Maybe you should implement the static function and then the one that we now already define that in terms of the static function. So in order to be able to print this type as well, even though normally it should be hidden, I want to have a static, yeah, it's also const expression. So that's string, toString, which just allows me to print this enum. And then we can implement this one basically in line in terms of that one. To return yep. And then let's make this one the static one. So that one now takes foo-e as the type. And then we can of course still do the exact same thing, just switch on the e. So now we have both. I think that, yeah, this is better. We make an implementation for the enum type itself. And then the toString member function can be implemented in terms of that one. I'm starting to wonder if I even need this actually. Can't wrap my head around it. So let's just make this work and then revisit the demand for this one. Maybe this one can be simplified or changed such that we don't even need that member function anymore. I don't know yet. Anyways, this does not compile because simply there is no toString currently that takes the foo-e. Because that only exists if my specialization exists. Oh, wait a minute, I was not defined at the top here. So the member function, this is literally, I mean, data here is of type T, and then we call the member function that does not take an argument. And that one is now implemented in terms of the static one. But no way that if I just have the enum type, that I can drag in the foo, I think. Because foo is a wrapper around an e, but it also has an int x, and if you can avoid it, you never want to create a foo or whatever. So if we want to directly print this, we simply have to call, of course, the static function and not touch foo, at least not constructed. So we're going to need a toString that takes a type. I could call it T, of course, because it's a template anyway, but let's call it an E. Because it's going to be the, foo-e. No const reference because it's going to be a enum, so why would you do that? And of course it's going to return a standard string, but probably wrapped in a standard enabled if. But okay, yeah, I mean it's a template, right? So template, type name E, and then standard string for now. And then we want to return, static function of T, wherever we get that one from. to string e. So foo, which is the t here, has a static function that just takes the e, and then that works. But of course we can only call this if t exists. So now we have to add a type name t. Sorry, type name t as well. Yeah. And then we have to match that. Let's see. I'm so confused that this whole enable if types. Why? Should we be using concepts instead of that? I think it's just too old. Yeah, I'm not using concepts here, clearly. We have to postpone this. I just want to use concepts because it's more modern. So let's not do this until we have the other part working and with concepts. Might still use this maybe, although I'm not even sure about that. So the concept works like we do template and then the name of the concept. We're going to call the concept, say, so instead of type name, you use a concept, and then you define the concept basically the same as this standard enable if thing. But everything I learned after I was 40 is not something that is ingrained in my brain. No, not even kidding, I think. So concept is too new. I just have to look it up. That is, I'm going to look at code that I already wrote to refresh my memory as well. Pretty sure it must be somewhere here in here, I think. Let's just do a find for everything, some type, some file, I mean, not a directory. And then grep for concepts, the capital C. I like this one. Just using the same kind of stuff. It's also defined in utils. Okay, let's have a look at square. It's not too old. I think I wrote that like somewhere in the past year. So yeah, two concepts are being defined. One is called that and the other one is called that. This one is super simple. Called concept built in, and that is equal to that, well, it must be either an integral type or it must be a floating point type. And this one says that means that if you have a type t, then you must be able to write a becomes time of the times becomes b must exist, and the result of that must be convertible to t. That is very close to what we have now as well, actually. So maybe I should just use this. I mean, also have a convertible. Did I leave my directory here? I guess I did. No, well, it was working here. Okay, so I'm going to define a concept. The concept is has toString, and we require that for a given t, it must exist. toString must exist. So that's this line. If you have a t, so this is much nicer, right? I mean, this is like how you had to do that in C++ 17, I think. Concepts are nicer. So if you have a t, then it must have a member function, and the result must be convertible to a standard string. Well, that would be this one. Can be converted to standard string. And I'm so sure about that I want to use concepts that I'm even going to delete all this. This is no longer needed. I'm going to do it like that. Yeah, I was implementing this, so that's no fair. And now we started work on the previous stuff again. What is this? Static member function. Blah blah toString for e declared with type qualifiers. Is it? Did I? Yeah, no, you cannot do that, of course. I probably just copied it and I forgot to remove the const. Actually, we added it in place. It's no longer a member function, it's a static function. It's all static member function, but no longer a non-static member function. Can't have a const there. Okay, that works. So now we switch to concepts. Good thing. Much better, much nicer. And yep, it was AI slop, because I think we just lost some time, because the stupid AI gives me this, if you ask it. I'm gonna give it a thumbs up. Thumbs down, not helpful. Not following instructions. What is wrong? Said I'm using C++20. So it should have been using concepts. So this works. You can now just delete this, the old stuff. Now I'm going to implement this one. So this is the has to string member function and a non-static member function. And this one, it should test the same thing, but then for a static one. I'm gonna put the type name E at the end, I think. This looks more like the one above, but then with something added to it. Sorry. So what exactly do we need here? I think TE must exist, right? The problem is that I think that the concept for E is only that it must be an enum. Not only though, it must be an enum that is I can't think of the name. Defined inside the class. I can only think of a concept that just combines E and T at the same time. Oh, that is possible, of course. Maybe we should just start with writing concept. I don't know. Can I have a concept with two types? Of course you can have a concept with two types. But I have no idea. Let's grab my own source code again for stuff that takes a concept with 2 types. Do I even have that? This is a lot less concepts than I thought I had used. I thought I had used a shitload of concepts. Why do I only get this? Not to mention that it should repeat. So it should have been, well, we only have this, and then it repeats here again and again in different directories. This thing has multiple types, but this is not a concept. It's just a separate concept. Okay, let's ask the AI again to at least get a clue. I'm not even sure how to ask it. Using C++20. Can you define a concept for a template function that takes that has 2 template arguments? Type name T and type name E. If not using concepts, where the demand is that E is an enum that is, how do you say that? Member type? Nested. Yeah. Member type is actually a thing, apparently. I'm pretty sure I said it was C++20, but no, Java, C#, Python. I didn't say that. It's calling nested. Okay, let's use nested. So the demand is that E is an enum. I can combine that, I guess. Is a nested enum of class T. Okay, and T has a static member function T, no, just toString. We already said it was a member function, so toString E. That returns a type that is convertible to a standard string. Note that I want to use concepts, not failure is not an error. Why so much? Well, at least, yeah, we have the template with 2 type names. Why type names? Oh, the concept itself, yeah. Let's look for the concept. Concept here. So we have a concept that is obviously the 2 types as a type name. And then it says E must be an enum, yay. And requires that T as a static toString that takes the enum value and returns something that is convertible to standard string. I'm missing something. I'm missing that E must be a nested type of T. I think the rest is already test suit. Okay, I can begin with this, I suppose. Oops. Yeah. Yeah, but now. I still don't know how to. The fuck. You can do a requires or something, I guess. Yeah, something like requires the concept. It's not the same as this one, where just put. I mean, that is still what is confusing me. That I know this, and it's probably the same as type name t, and then requires the concept. But as soon as you have two template arguments, you can't use this anymore. It's just not how it works. I think you have to do it like this. I would say if it compiles, it works. Let's try this. If it bloody compiles, well. Am I also testing it already? I think so, yeah. Okay, so no, I'm not testing it actually. The last line must be. Still doesn't work. Why not? Error, no matching function equal to blah blah. There are two candidates. Candidate 1. This would be candidate 1. I don't recognize it, so I'm going to go here. That is the one that I want, right? Candidate 1. Requires concept has static to string. Standard string utils has to string e. No. That's not a static member function of t. It should be. Could not deduce template parameter t. Makes sense. Oh, that makes a lot of sense. That's going to be problematic. That's going to be very problematic. Yeah, do. I think that we need to provide a way to convert the enum type back to foo, because otherwise you have only the enum type. How are we going to find? Well, actually, it is of course nested. Being that type is there's only one type of that type, and that is the type that is nested in foo. So I should be able to find the type foo back from that. No. Well, maybe not, but let's Google. How do you do that? Foo. Something with the template, and then find class of nested enum. How to access nested template parameters that are enums. Not sure that's what I want. Enum inside a templated class. Nah, not really. Accessing an enum value in a nested template class ... That could be it. Doing a nested class and enum types. It's a nested class. Class nested template plus inner enum. The third nested template needs to be a non-type template parameter, which is, I think I'm not searching for the correct thing. Let's ask Grok. Grok is good with, I hope. No, I don't know. Maybe not. DeepSeek. DeeperSeek. Uh, 0 plus 20. Let E, B, A, and nested enum. For example, foo E, where foo is a class and foo E is the nested enum inside foo. Is it possible to write a template function that takes one argument, pass E, no, pass a variable of type E, and deduce the type T that is the class that has the enum ES nested type. I don't know. The thing is a little intelligence to now understand what I was meaning. Containing class. Okay, it knows what I want at least. See, I couldn't do that. Like, I couldn't find the right words. But C++ deduce enclosing class from nested enum. Very good. C++ template deduce outer class from inner enum. Also very good. I recall bullshit. You don't recall anything. There's no direct way to get the enclosing class from a nested type. Generically in C++. But maybe with some template magic it's possible, though macros, other tricks aren't standard. I think it's done searching. results found, browsing results. Okay, let's just scroll to the bottom. It seems like that deducing the enclosed class from a nested enum includable is not directly possible without manual setup. Research suggests manual specialization, like traits, is needed for each case. But that is really annoying. I mean, yeah, it's plausible. It's kind of stupid because you have to type. You can print the type. It's like I could demangle the type and then find the enclosing clause. So yeah. It kind of repeats itself. It's 12 years old. Not sure this is what I want to know actually. Is it even on topic? Yeah, this is well, almost exactly. They're using class here, but I'm having a class A and an enum B. And just having the type B, I want to find A, which is totally possible. I mean, it's uniquely defined. What that B is like literally A colon colon B. So yeah, I mean, if that is not possible to get the A from the type of AB, yeah, they want to use a trait. That's the only answer. Okay, the one last thing I want to try, and that is ask the gurus on IRC. That's always a definite answer. I'm gonna go to IRC. What? Oh, I rebooted and I never started it. think you need something like a strip, the type strip. Strip of one scope can also only be done at the end, of course. You know, strip of the beginning, then you don't know what you have anymore. Get maybe it's a worthwhile search, like C++. Yeah. Yeah, okay. Yeah, it's okay. Yeah, it's not. It doesn't. It's not possible. Could demangle the type. No, and you still don't have the type, of course. You just have the string. Oh, what? The type isn't uniquely defined. Okay. So in that case, if you have, well, I'm not sure actually. Is that true? So no distinction between A and C in terms of B. If you do it like that, I would say you define B inside A. And then you borrow it and put it in C, but it's still defined in A. Okay, so type trait it is then. Now I have to find back, of course, where that suggestion was. I guess here. This is very global. I would rather do something just local to full. Is that not possible? Probably not. If you just have the foo as type, then you cannot use ADL to look inside foo. Or can you? I mean, for static functions, can you? Oh, that would be funny. That would be super funny. I don't think ADL works for class scopes. It only works for namespaces, doesn't it? Let's try that though. So let's drop the whole concept, which doesn't work. So I'm just defining a global, well, inside this namespace, which we then again put inside the test, but basically a global function which takes any type E. And maybe that's not going to compile. Let's at least demand that E is an enum. Requires standard is enum. V, I guess. E, I don't know. I'm just trying something. And then no, this is nonsense. No. The idea is that no, wait. Zip. Just not have this at all. I want to test if ADL not just works for the enclosing class. So E2 here has the type foo2. If then it looks for static member functions inside foo because of ADL, it would already find it. I think that didn't work, so, but well. Foo has a static function here. So if ADL also works for classes, then this should already compile. Yeah, that doesn't compile, of course. I mean, a static function always needs a class scope in front of it. That would be ridiculous. There is only one way that this is going to call a static function of foo, and that is if you put foo in front of it. So maybe I should just, you know, demand that, because as a programmer, you should be aware that E2 here is not foo. It's the internal enum type inside of foo. That's a given here. So the only reason I would want this to work with toString is when this appears inside a template where E2 sometimes is foo and sometimes is foo E. And then you still want it to work. Otherwise, I might as well demand that you put that in front of it. I think this compiles. Yeah. Okay, now let's see if we can support that, and that would only be for the template case, if you ask me, but okay. We can support this, provided that then the coder adds some overload for this enum. Specialization, I mean. Put T at the end then. So now we deduce T from E simply by calling, yeah, or not. Well, yeah, always. Okay. So how is that done? Again, rename enclosing clause. Well, I'm gonna use enclosing clause. So we have enclosing clause type. Type name, of course. So given an E, we also have a type T that is the type that is defined in enclosing clause or with template parameter E. And of course, if that does not exist, then yeah, the template doesn't compile. Therefore, it's skipped. It's not an error. Yeah, well, I guess everyone I see is agreeing that's not possible. I wanted before. Okay, we'll have to do it all like this then. Okay, now we must have the enclosing clause exists. This is inside the namespace utils has toString, so we can just define that. Oops. Make a template clause. Doesn't even have a type. And then this must be specialized for foo E by, well, the guy that defined foo. So then it's not a template anymore. But you can specify it here. It's foo E. Jesus, I can't type. Closing clause is not a template. What am I doing wrong? What the fuck? How do you do that? Probably gave an example anyway. That's what I did. Template, no template, strict and closing clause, just give it. This is exactly what I did. What the... I'm convinced that this is correct actually. So yeah. I put it in the wrong namespace. That's why. It's not, template is not defined in test. I doubt I can do a using and then define it here. Let's just define it in the correct namespace. Let's put it all the way down here, or is that not possible? I think it should be possible. Namespace utils. Blip. Yeah, that's why it said it's not a template. It meant it's not a template in namespace wherever we were in test, I guess. Still the same error. Oh, wait a minute. It's not as bad as before. Well, actually it is. Still. But it just doesn't know what foo is now. Yeah, what? Because now we're no longer in test. But, still the same error, right? Enclosing clause is not a class template. Explicit specialization of non-template utils has two strings enclosing clause. How is that a non-template? What? Not repositories. Paste side. So there's a bolt. Vim. Delete. Get my namespace. Define this. And the namespace. Define test. Define foo. And test. Add specialization. Shit was still left. Okay, did this compile or did it not compile? There's nothing to compile, you say. I should have tested it on one box. Well, there's red lines, yeah, but I don't see the error. Oh, there's no foo here. Yeah, that doesn't work. Enum foo. That is the error. Forget AIs. Never ask AIs. That only costs times. I should have typed it here in Google. Specialize a template struct. That is actually exactly the way we are doing it. Exactly the way I'm doing it. Okay, apparently I was blind. The reason is that I typed an S too many here. Different namespace. Hoppa! How the hell did an S come here? Okay, so now this works as well, but only if you add this. Yeah, the question is then, of course, can we not do this without having to, you know, leave test and enter this? I think we could do that if you just add here the whole shebang. And then, well, you definitely should be able to do this here. Error. Global qualification of a class is invalid before opening the brace. What? Opening brace? What? No, that's what I saw here somewhere. This. Okay, specialization in same namespace. Same. What is same? And or double. Oh, it needs a forward. Oh, this is a definition. Ugh. So that belongs to that one. So you can do this, but then you add the definition. Well, it still has to be forward declared then, apparently. That is pretty annoying. Yeah. Yeah, okay. But okay, so I think that this is only needed if you insist on being able to do that, which is kind of nonsensical because, I mean, unless you have a template where the type can be either foo or foo-e. Otherwise, you might as well put foo in front of you. If you just know that this type is always foo-e. So the last step is to move this to utils and then add all that as documentation. Yeah, so if someone does not do this, this is no problem whatsoever, of course. Just as long as you don't do this or put foo in front of it. That still works. Yeah, well, I already have the credits with to print. Example codes. To string. Let's not talk about this static yet, actually. Simply toString for... I don't know if that should be a const expression though. Maybe sometimes it should and sometimes it shouldn't. I mean that the print2 also was not a const expression, well, but that's logical. So I don't do this. I don't use the type directly, the foo e. I mean, if you mimic the enum class by just wrapping the enum inside the class, then I don't think the whole code needs to know about that. I mean, in this case, you use the foo e. This is a foo e type, and then, well, this one, I mean. But that then constructs a foo, which is exactly the same as here. We just have a foo, and well, this prints foo, but you can do standard. Sorry, you can do two-string the foo here, and E1 is also foo. There's no difference. I mean, if you put two-string around it here, a foo is a foo. It doesn't matter that it was constructed from the enum. So I don't even have to talk about the enum, I think. But we do support the enclosing clause trick. We'll still should talk about it, but that then only, well, is for types that are being enclosed by a foo. Might as well remove this enum, I guess, but I mean, why would it need to be an enum? It could be any type, really, as long as for that type a static member function exists in T. So it is a non-static member function that does not take an argument. Would still call it suggestively an E, because usually you would have, I think only use that for an enum. Or call it n of nested, but that's, n is usually used for the namespace. Oh yeah, just call it E. This must have a static member function to string E. This does not take anything. And if it does take something, E is distinct from T, of course. I'm just gonna throw this one away. It just no longer has to be an enum. Yep, on the other hand, now it is not an enum. We have to pass it like a const reference. You don't know how big it is anymore. But I don't think a compiler would pass it by reference if it is an enum. It's gonna pass it by value anyway. It's allowed to do so, I think, because a reference is an alias. So it's doesn't really guarantee that it is a pointer, you know. I mean, just compiler is, I think, allowed to ignore the reference if it knows that the type is not larger than a pointer. And you don't take the address of it, of course. Okay, so comparing it to this, call static member function t2 string passing an E when using toString te console. Hello. Someone says in the chat. Yeah, nonsense. E is the type, not the subtype. What the hell am I editing to string.cxx? Arg. Nah, I don't think I edited the other thing. Let's just copy all of it. Delete it even. Nah. Does it still work? I think we can do this. Oh, wait a minute. I wanted to do this, actually. I think we can do this. Oh, no, I would have to for declare foo-e. I don't think that's possible. Or, maybe it is possible. Well, let's first test it like this. Goodbye. Definitely missing something here. Convert as type traits or so. I have type traits. What? What is happening? Concepts then. Concepts. I even suggested. Don't have to look it up anymore. Great grandfather. Concepts. And string. Blah 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 blah. So I would like to put this earlier for some reason. Actually, just in a header. Like say, I could put it in this header, like assume that the class foo is a header. No, that wouldn't work. Well, that would work, of course. This is not generating code. Definitely put it in here, but now we are in the middle of namespace test, which is annoying. So then you wonder, can I not put it even before that? And that then in turn would only be possible if, of course, test foo already exists. Sorry, test foo-e already exists, and test foo as well. So can I for declare something like class test foo, just to keep it short. And in, oh, this is not going to work. The very idea. Foo-e. Well, that would be nice. I have to test this. Test has not been declared. Yeah, it's kind of makes sense, I guess. Space test. Might as well put that one in too then. I don't think, no, this is not going to work. Of course it's not going to work. he does not name an enumeration in test foo. Nope, these are not working. But suppose you really wanted to do it like this, you could do a foo base, put it in there. But yeah, now it's not foo, now it's foo base. Okay, the type, no, the type is not foo base. We don't have a, well, yeah, now the type is that, but then I have to move it over there. So we could make this foo base, and then the whole enum must move there. That should work, of course, because now it's the whole foo doesn't even exist anymore. Then that is a base class. I don't see the use of using a class anymore. Let's use a struct here. The struct only has the enum defined. Ta-da! And then you can define the enclosing clause. And then you can do the real thing. Now I still have to document this. What you have to document is the use of this function. So if t has a static function toString that takes any type, then you can use this. No, I don't even. Well, actually, you're passing C, and we want to use argument dependent lookup ADL. So we're going to look for the toString inside the namespace n. That, I mean, otherwise we would never. Oh, this is also wrong here. Yeah, otherwise we would never find this definition to begin with. You have to look in n, which means that our argument must be in n. So yeah, this must be in n. So yeah. I would almost wonder why it works at all, because well, we have NB. Is it also going to, if ADL also look in all parent namespaces? Let's test that. Apparently it looks in the namespace of the enclosing class. If C is an enum inside B, then it also looks in N. But what if C is just an other struct, which is defined not in B, but in a namespace M, which is in N? And it can't hopefully find any toString in namespace M, then there's a chance it's gonna look in N, but I'm not sure. Let's just test it. Anyway, this, if it is correct, is now saying that you can call toString on any type as long as that type is defined in N, and there exists a type B that has a static function with a toString that takes that C. So I'm gonna do this C here as well, that this is inside namespace N still. Let's just explicitly close N here, because now it says then from any namespace N, which is annoying because that's what we do here as well. Okay, we'll just start all over. That won't work if you do it by value. So if you have a class or a struct that defines a member function or a static member function called toString, respectively taking an argument or if it is static or not, if it is not static, then you must do this in the namespace where that class is defined. So here as well, if you have a class that defines a static one. And then this works, and only then this works. For any namespace you can do this, provided closing clause. I think I have everything now, except I want to test. Still, it still compiles. If it compiles, then it compiles. Then it works. Bleep. And I wanted to test if ADL also looks in parent namespaces. So at the moment I have a class with an enum in it. Where's my enum? Here. Yeah, I did something with the base class. Let's just start over on the test 2, because it gets a bit messy otherwise. I'm going to call this, let's say we have a namespace N1, and inside that we have a namespace N2, and inside that we have a struct C, and then I have my struct B. My B has a static standard string, toString, that takes a C. So if ADL works with nested namespaces, it's not going to find toString in N2, but there is one defined in N1 because we have, well, that's not yet anyway, but we're doing this using inside, just inside N1, not inside N2. So there is a toString in N1, the catch-all toString, but there's no such thing in N2, because just I wanted to test it. Kind of silly, because I mean, it's the reason that you do this is because that namespace contains a class that has a toString defined. Well, no, sorry, that's not true. So that's for that reason. Yeah, okay. Well, maybe, no, never mind what I said. Yeah, it's just like this, actually. So I even copy the comment from the example code. B defines a toString. Therefore, we have to do this. Otherwise, it will never find it. But that doesn't hold for namespace N2 because this is just some type. This doesn't have a toString member function. And then we try to call toString with C, and the question is now, is ADL going to find that? Because it doesn't find it in the namespace of C itself. And then will it continue with the namespace of the parent is the question. So will it look for toString in N1? If so, then this is defined in N1, N2 was closed here. So then it will find this one, if that works. And that thing then will just, well, it can go there. So that would be this one. That will then call the static member function on T, where T is returned as the type of the enclosing class of E, which is C then in our case. And we added a specialization for that. I'm looking for it. I cannot see the specialization. We don't have a specialization. Okay, so that is not going to work then. It has to be able to figure out that we want to call B toString when being passed to C. So I still have to add that specialization, and I have to do that below where C and B are defined. That would be like here. And that must unfortunately be done in namespace utils has toString. Template. What was it? Enclosing class N1 and 2C. Using type is N1B. C has not been declared. It's the first error. Unqualified ID before This must be a type name. Otherwise it doesn't know that it is a type. But I don't get it. Error, expected unqualified ID before opening brace. Usually that means that it didn't recognize something as being a type. But oh, there's a struct missing. No matching function for call to string test foobar foo e. There are two candidates. Template argument deduction substitution failed. Constraints not satisfied. In substitution of template class et requires with e is test foo base foo e and t is test foo base. So I did at least find that one. Required from here. Required for the satisfaction of concept has static to string. But yeah, but the foo base does not have the to string, the static to string. That is foo. Let's try just using foo here. But then foo must be defined. It was the whole idea that he can do this before foo was defined. It's kind of a fail in it, I suppose. Total failure. Let's ignore this attempt here. Let's just move this back to foo. No base. And the specialization must go down here below test. Ta-da! Ta-da-da-da-da-da. It works. Do you think the ice cream man is still selling ice cream? Because I feel like giving myself an ice cream. It means I probably have to hurry. I had the feeling that he's... they say we are open until it gets dark. It's not dark outside yet. But it is 9:30. And then you come there and then they are closed anyway. And then I told him, hey, you say you're open till it gets dark. And then he told me, yeah, but I'm getting old. And the paper on the door that says we're open until it gets dark is a decade or 2 decades old. And he just couldn't get it off the door anymore. But okay, I can go for a walk. If then there is no ice cream, it's actually more healthy. I'm going to stop the stream here because it works. going to get ice cream. Have a good day further.